Wake up in the morning feeling like P. Diddy.
Hey, whatever,
Grab
girl.
my glasses, I'm out the door. I'm gonna hit this city.
Let's go.
Before I leave, brush my teeth with a bottle of Jack. Cause when I leave for the night, I ain't coming back. I'm talking pedicure on our toes. Trying on all our clothes. Boys blowing up our phones. Drop top and playing our favorite CDs. Pulling up to the parties. Trying to get a little bit tipsy. Don't stop, make it pop. DJ, blow my speakers up tonight. I'ma fight till we see the sunlight. Tick tock on the clock, but the party don't stop. No. Don't stop, make it pop. DJ, blow my speakers up tonight.
The dendrite is a part of the neuron that receives signals from other neurons. The mammalian sheath protects the axon as it is made out of some fat substance. Additionally, it contains electrical energy that is known as the action potential. The axon is a part of the neuron that transmits signals. It transmits the signals from the cell body and the soma to the terminal branches. The terminal branches are the parts of the neuron that sends messages to other neurons, muscles, or glands. A neurotransmitter receptor is a receptor made out of protein. It is activated when it comes into contact with other neurotransmitters. This allows cells to communicate with each other through chemical signals. Receptor binding is the action in which a neurotransmitter binds to its corresponding receptors.
You break me down, my heart it pounds, yeah you got me with my hands up.
This diagram is known as a neurotransmitter release. What it shows is neurotransmitters leaving their signal emitting cell into the signal receiving cell. The storage vesicle is where the neurotransmitters are stored inside the cell.
The party don't start till I walk in. Don't stop, make it pop, DJ blow my speakers up.
The circles and the triangles in the diagram represent different neurotransmitters. Now, we are going to learn about ibuprofen and how it interacts within our body.
Woo! Ibuprofen is an anti-inflammatory drug which can be used to relieve headaches, sore muscles, and inflamed ovaries. It can also be used to control fevers, ease pain, inflammation, and swelling.
Ibuprofen affects chemicals in the body called prostaglandins. These prostaglandins are local hormones, which are those that are released in responses to illness or injuries and can eventually cause a very high fever.
The pain is felt where white blood cells accumulate in place of an injury. Ibuprofen then interferes with the actions of enzymes called cyclooxygenase, which catalyze the conversion of a compound called arachidonic acid into prostaglandins, which are then removed by the ibuprofen.
Anti-inflammatory drugs go into prostaglandin synthesis. These drugs exhibit cyclooxygenase, which are the enzymes that catalyze the synthesis to form prostaglandins. When ibuprofen is incorporated into the body, it interacts with a hormone called prostaglandins.
The structure of the ibuprofen and the structure of the prostaglandin are very similar. They both have alcohol groups, they both have carboxylic acid groups, and they both have a ring structure, as well as some carbon single bonds.
Additionally, they vary in the fact that the ibuprofen has a double bonded ring, while the prostaglandins has 2 carboxylic acids instead of 1.
Now we're gonna talk about
equilibrium! Ibuprofen first causes an imbalance in the acid base in the stomach and the intestine. Due to the presence of ibuprofen, the enzyme is being stopped from doing its job, causing an imbalance in the system.
The job that the cyclooxygenase does is that the enzyme is responsible for the production of prostaglandins. This makes it evident that ibuprofen is an antagonist as it stops the production of prostaglandins.
Prostaglandin is released to signal pain. With this in mind, ibuprofen blocks the production of prostaglandins and therefore decreasing the feeling of pain. Thus, decreasing prostaglandins, which is the reactant, means that the rate of the forward reaction is decreasing and therefore the reaction will shift backward.